My name is Dan Cox. I'm a professor here at Oregon State University in civil engineering, and my role in this project is to do experimental work to look at the forces by hurricane waves and surge on residential structures. The overall goal of our project is to come up with a better way to estimate the damage on residential structures that are being impacted by hurricane wave and surge. I'm also working with a colleague, John Vanderland, at Colorado State University, and he's doing the computational work for this project. So the new methods, they can be used in community decision-making tools. These are tools like FEMA's HAZAS computer model to see how much benefit there would be in elevating a home in a coastal area that's being subjected to the flooding and surge. The work that we're focused on here is the part that estimates the damage to the residential buildings due to waves and surge, because there are a lot of residential buildings on barrier islands and other locations that are close to the shore that have been vulnerable to big hurricanes in the recent past. The tests that we ran at Oregon State University were conducted in a large, shallow tank, and it's capable of reproducing hurricane waves and surge that hit the shoreline. And then on the shoreline, we put two buildings, and these were replicas of the buildings that were hit by hurricanes on the Texas coast. So we're designing these buildings to be at grade. That means built at ground level or with a small crawl space. And then we also had a building that was elevated. So the test allowed us for the first time to see how wave and surge levels cause progressive damage. So that's how the walls of a building are being damaged during a storm. And then the final damage at the end with the entire building getting knocked over and washed away by the storm. So the data that we collect, the wave and the water levels, as well as the pressure, force, and damage to the buildings, allow us to come up with what we call a fragility curve. And this is a relationship between the storm hazard and the amount of damage that we're going to see on these buildings. So for the residential structures, what we're learning is that they're not very good at resisting waves. It's much better to elevate, to get them as high as possible to avoid the hazard in the first place. There may be other structures that are made of stronger materials like steel and concrete that could resist some of these forces, but that's really research for another day. What we're finding for the residential structures, it's much better to avoid the hazard than to try to resist it. Each year we had 2 students part of this project, and they got to help design, build, and test these structures in the laboratory. And I think it's had really a great impact on their desire to want to go on and do this type of work for really just trying to improve the coastal communities and how they can better adapt to hurricanes and other hazards on the coast.